Multiplying and dividing using algebraic fractions. We're going to start with some numerical examples. So to begin with, 2/3 multiplied by 1/5. We can very simply multiply the numerators together, multiply the denominators together, which gives us 2 over 15. 2 and 15 do not have any common factors, so we can't simplify that any further. Next example, 2/5 multiplied by 7 over 6. Now, 2 and 6 both have a common factor of 2. They both divide by 2. So 2 divided by 2 is 1. 6 divided by 2 is 3. So this calculation becomes 1/5 multiplied by 7 over 3. This then becomes 7 over 15, which again does not simplify. In the next example, we can cancel down common factors even further. 10 and 5 both divide by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. 3 and 18 also have a common factor of 3. 3 divided by 3 is 1. 18 divided by 3 is 6. This leaves us with a calculation of 1/2 multiplied by 1/6, which is very simply 1/12. A common mistake that people try and make when multiplying fractions together is to try and give the fractions a common denominator. You don't need to do that. That's when you're adding or subtracting with multiplication. Ultimately, you multiply your numerators, you multiply your denominators. In the next question, the first number is an integer, 7. Then it's multiplied by 3/5. We can rewrite 7 as 7 over 1, then multiply by 3/5, which gives us 21 over 5. What about some division calculations? 4/5 divided by 2/3. You may remember from previous fraction work that to divide one fraction by another, we take the reciprocal of the second fraction. Some people like to call that flipping the second fraction, taking the reciprocal of the second fraction. We then multiply the two fractions together. Before we do that, we could cancel out any common factors. 4 and 2 both divide by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. So this becomes 2/5 multiplied by 3 over 1, which is 6 over 5. Same with the second division. The first fraction is 9/10. The second fraction, we take the reciprocal to give us 20 over 3, and we then multiply. Cancelling out common factors, 9 divides by 3 to give us 3. 3 divides by 3 to make 1. 20 divides by 10 to make 2. 10 divides by 10 to make 1. So we have 3 over 1 multiplied by 2 over 1, which you could write as 6 over 1, but the best answer, the simplest answer, is of course 6. In the next question, we have mixed fractions involved. So 1 and 2/3, which we will rewrite as 5/3. 1 multiplied by 3 is 3. Add this 2 up here gives us 5, 5/3. This is being divided by 4 and 3/5, which is 23/5. We then rewrite the calculation as 5/3 multiplied by 5 over 23. Now, a common misconception here, people try and cancel out the 5s. Unfortunately, we can't do that because they're being multiplied. One isn't being divided by the other. So all we can do is multiply 5 by 5, which gives us 25, and multiply 3 by 23, which gives us 69, and this fraction doesn't simplify any further. There are no common factors. In the very last question, we rewrite the first number as 4 over 1. This is being divided by 1 and 2/3, which is 5/3. So this calculation becomes 4 over 1 multiplied by 3 over 5, which is 12 over 5. Now we move on to look at some algebraic examples. The first example, 5x over 2 multiplied by 3x over 4. If we multiply the numerators, we will get 15x squared. The denominators multiply to give us 8. There are no common factors, so we cannot cancel this down or simplify it any further. In the second question, however, 2x squared and 4x both divide by 2 and by x. We can divide by 2 to give 1, 4 divided by 2 is 2, and we can also cancel down this x squared into an x and this x into a 1. We can also simplify 3y cubed and y divides by y to make 1, 3y cubed divides by y to give us y squared. So if we write out what we actually left with, we have x over 1 multiplied by 3y squared over 2, the answer to which is 3xy squared over 2. In this next example, there are a couple of different ways in which we could do this. We can see that 2 and 8 are going to have a common factor. They both divide by 2 to give us 1 and 4. And you may notice that 3x plus 9 is 3 times x plus 3, so we do have a common factor of 3. A better way of seeing this might be to rewrite the second fraction in factorised form, so 3 brackets x plus 3 all over 4. We can then see that this x plus 3 and this x plus 3 will cancel, leaving us with 1 over 1 multiplied by 3 over 4, which of course is 3/4. In this next example, there are no common factors for us to cancel, so all we can do is multiply the numerators together, multiply the denominators together. Now, people are often, again, very tempted to try and cancel down the x's or simplify them, but that you cannot do that. There are no common factors, and this does not simplify. What about division? The first fraction is 2x plus 3 over 5. The second fraction becomes 35 over 8x plus 12, and we're multiplying. 5 divides by 5 to make 1, 35 divides by 5 to make 7. And if we factorise anything that factorises, the denominator of the second fraction becomes 4 bracket 2x plus 3, which means we can cancel 2x plus 3 and 2x plus 3, leaving us with 7 over 4. What happens when quadratics are involved? Well, the key thing is to factorise first. Don't be tempted to cross out x squareds and try and cancel x's or cancel numbers. You have to factorise first of all. If we do this, x squared plus 5x factorises to x plus 5. X squared plus 2x plus 1 factorises to x plus 1, x plus 1. This is multiplied by x plus 5, x plus 2, all divided by x plus 5, x minus 5. And notice here we have a difference of 2 squares. We can now cancel down any common factors. One of these x plus 5's in the numerator will cancel with the x plus 5 in the denominator. We can't cancel them both, we can cancel one of them. There are no other common factors that cancel down. Don't be tempted to try and cancel down these two brackets here. And the final answer we can write as x plus 5, x plus 2 in the numerator, and in the denominator, x plus 1, x plus 1, and x minus 5. And we do not need to try and expand any of these brackets or multiply any brackets out. We can leave this exactly as it is. For our last example of division, we need to make sure we do things in the correct order. So the first thing I'm going to do is rewrite the calculation as a multiplication. We're going to take the reciprocal of the second fraction, and ensure that we multiply rather than divide. We're then going to factorise completely. And then cancel out any common factors. So we can cancel out x plus 3, x plus 3, x minus 2 and x minus 2. This leaves us with x plus 3, x minus 7 in the numerator over x plus 5, x plus 2. There is no need to expand the brackets unless you have a particular reason to do so. We can leave the final answer in this format. There is nothing further to cancel, no common factors. We leave our answer in this form.